Hey guys, welcome to Stat 441. And this lecture presents a few examples using the normal distribution and the standard normal table. Here's the first example. In this example, we have a group of Japanese environmental engineers investigated the ability of a hybrid tomato plant to produce miraculin. For a particular generation of the tomato plant, the amount Y of miraculin produced had a mean of 105.3 and a standard deviation of 8.0. So here we are assuming a normal distribution for this, and then we have the mean and the standard deviation for our variable y given to us. Based on this distribution, we need to find these three things. First, what's the probability that y is greater than 120? So basically, compare this with the mean. We have 105 mean and standard deviation 8. What is the probability that y is greater than 120? Second is find the probability between 100 and 110. And the third question is find the value A for which probability of y less than A is 0.25. So in this, the probability is given. We need to figure out the value of A. Okay, so let's look at the first part, finding the probability of y greater than 120. So remember, we discussed this in the previous lecture. So this first step is to always convert the y to a z, which is the standard normal distribution. So y is converted to a z, and this number, when we convert it to a standard normal, it will be 120 minus the mean divided by the standard deviation. So now this changes our problem statement to probability of z greater than 1.84. If you draw this on the distribution, this is now we have in the form of a standard normal distribution. The center is at 0. The mean is 0 now. So center is at 0, and this is a distribution with standard deviation 1. Z is 1.84, so this is 1.84 away from the center, and we need the probability of greater than. So that is the area on the right hand side. Okay, now remember the table of the standard normal distribution that we have gives this area. It gives the area between, if you look up 1.84 on the table, it will give us this area between 0 and 1.84. Another thing to remember is, due to symmetry, we know that area to the right of 0 is total 0.5. So whatever we get from the table will be this area, and if you subtract that from 0.5, we get the area to the right of 1.84. So that's the technique that we will use. So from the table, we can figure out the probability of z between 0 and 1.84 is 0.4671. 0.5 minus 0.4671 is 0.0329. That's our answer. Again, a quick look at the tables. This is what the table looks like. That's the z value. Those are the z values. On top of this, the second decimal place. So whatever you're looking for, let's say you're looking for, let's check the number once again. It's 1.84. So you locate 1.8 here, okay? And then 1.80, 1.81, 82, 83, 84. So this should be your probability that we subtract from 0.5. Okay, now let's look at this next example. In this example, we need to find the probability that y is between 100 and 110. So again, step 1, we should all convert this to a z. So y is converted to a z. For the two numbers, subtract the mean divided by the standard deviation. So on both sides, 100 minus 105.3 divided by 8. On the right hand side, we have 110 minus 105.3 divided by 8. So this makes our values to be negative 0.66 and 0.59. Now, if you look at how this will show on the normal distributions, this is 0, where the center is, negative 0.66 on the left hand side, and 0.59 on the right hand side. The table gives us, if you locate 0.59, it will give this value, okay, this area. And then corresponding to the negative 0.66, the table doesn't have negative 0.66, but it is symmetric. So if we look up 0.66, that should give us the same area. The total area, if we add these two, should be our probability of z between negative 0.66 and 0.59. Okay, so again, we will look up 0.66 and 0.59 from the table. So 0.5 and 9 is here, and for 0.6 and 6 is here. So that gives us the two numbers, 0.2454 and 0.2224. We add them up and we have the answer. Here is the third part, slightly different. So in this part, we have the probability or area given to us, and we need to figure out the value of a. So this is what we have. We have probability of y less than a is equal to 0.25. So again, let's convert this first. So a minus the mean divided by the standard deviation would be equal to 0.25. So let's call this number z0 that we can look up from the table. Now, to equate this to a number that we can look up from the table, this is what we need to figure out. So this area is 0.25. Okay, again, if we cut it in the center, then the remaining area is 0.25 as well. If we look up from the table, the value of the z corresponding to an area of 0.25. Okay, and the way we do that is we will locate the number 0.25 or the number closest to 0.25 within the body of the table. Okay, so 0.25 corresponds to 0.67 in the table. So this is 0.67, and this number is the closest that we can get to 0.25. And we have to basically work backwards, locate this value first, and then find 0.67. Okay, now in this case, it will be in negative 0.67 because we have our z value on the left side of the 0. So our z value is negative 0.67, and this was the equation that we had here. So a minus 100.53 divided by 8 is negative 0.67. And when we solve for a, we get 99.94. So the value of a is 99.94 here, which corresponds to 25% area on the left side. Or probability of y less than 99.94 is 0.25. Okay, so in these questions, it always makes sense to draw first and see what is that we are trying to find, and then solve it corresponding to how the table is given, which is the area on the right side of 0. So once you have that figured out, you will have to decide whether you need to add the extra 0.5 or subtract from 0.5, depending on what we are trying to solve for. Here is another example. In the mobile networks and applications, December 2003, RSVP was applied to mobile wireless technology. A simulation study revealed that the transmission delay of a RSVP-linked wireless device has an approximate normal distribution with a mean of 48.5 milliseconds and standard deviation of 8.5 milliseconds. Okay, what is the probability that the transmission delay is less than 57 milliseconds? And then what is the probability that transmission delay is between 40 and 60 milliseconds? Okay, so we have to first think of everything in terms of area on the normal distribution. So we know that y is normally distributed, mean is 48.5, sigma is 8.5. Now in this question, probability of y less than 57. Let's first convert this to a z. So 57 minus the mean divided by the standard deviation of 8.5 gives us probability of z less than 1. Okay, so now let's draw this on the standard normal distribution. Mean is here, 0, 1 is here. And we need the probability of z less than 1. So this whole area. Okay, now we already know this is 0.5 because it's just the midway, 0. To the left is 0.5. And if we can figure out this part between 0 and 1, that will give us the total probability. Now between 0 and 1, we can find this from the table. If we locate z is z at 1.0, the second decimal place is also 0, which is 0.3413. And when we add that up, we get 0.8413. Okay, so in this case, we had to add that extra 0.5 because our value of z was towards the right of 0. Okay. Another one here where we have y between 40 and 60. So first step, convert these to z values. So 40 minus the mean divided by standard deviation is -1. 60 minus the mean divided by standard deviation is 1.35. So this time we have -1 located on the left side of 0, 1.35 located on the right hand side of 0. So from the table, we will look up this area when we locate z of 1.35. So that gives this area. And for -1, it will be the same as z equal to 1. Okay, because of symmetry. So when we locate z equal 1, that gives us this area. We add these two. So 0.3413 when z is 1.0 from the table. And then locating 1.35 will give us 0.4115. And the total is 0.7528. So here are the examples for the normal probability distribution. Remember, the first thing you should try doing is converting your problem from y to a z problem, then drawing it on the z distribution where the center is 0 and standard deviation is 1. Okay, and based on the shaded area that you need, you can figure out the corresponding probability distributions from the table. And then another thing to remember is that this graph is symmetric around the center, and for corresponding z values, so area to the right of 0 up to, let's say, 1.5 z is the same as area to the left with -1.5 z. All right, so that's for this video lecture. Thanks for watching.